Okay, so welcome back. We're going to look at section 2 of your final exam review, which is solving quadratics by factoring. The first thing that we want to consider, and one of the most useful properties that we're going to have throughout this section, really most of algebra, is called the zero product property. And that's that if we have a times b, where a and b are any expressions you want them to be, if a times b is equal to 0, then we can break this up into two separate equations that a is equal to a is equal to 0, or b is equal to 0. We're going to use this a lot in this section and anytime we're dealing with quadratics or polynomials. But now that we have this, let's move on and look at number 13. So for number 13, we have x minus 6 times x plus 2 is equal to 0. So for something like this, it's already factored for us. So the hard part's done. Now we just need to find what x is equal to, and we can break this up using our zero product property as x minus 6 is equal to 0, or x plus 2 is equal to 0. When we solve both sides of both of these equations, we add 6 to this one, to both sides, and we get x is equal to 6. And when we subtract 2 from both sides of this one, we get x is equal to negative 2. And so this is our final answer for this problem. Let's look at number 14. For number 14, we have x minus 7 times 4x minus 5 is equal to 0. Same thing, this is already factored for us, so that's nice. We have x minus 7 is equal to 0, or 4x minus 5 is equal to 0. For the equation on the left, we can add 7 to both sides. We get x is equal to 7. Or, for this equation, first we need to add 5 to both sides, so we want to do any addition or subtraction first. We have 4x is equal to 5, and then dividing by 4 on both sides, we have x is equal to 5 over 4. So these are our two solutions. We have x is equal to 7 or x is equal to 5 over 4. For number 15, we have 7x minus 4 times x plus 5 is equal to 0. And again, using our zero product property, we're going to break this up into two equations. We have 7x minus 4 is equal to 0, or x plus 5 is equal to 0. We can add 4 on both sides of this equation, and we get 7x is equal to 4. Dividing by 7 on both sides, we get x is equal to 4 over 7. For the other one, we can just subtract 5 on both sides, and we have x is equal to negative 5. So we have x is equal to 4 over 7, and x is equal to negative 5. All right, so for the next problem, we have, let's see, that was 15, so on to 16. 16, we have 7x plus 2 times 3x minus 7 is equal to 0. Zero product property gives us 7x plus 2 is equal to 0, or 3x minus 7 is equal to 0. So for the equation on the left, we can we can subtract 2 from both sides. We get 7x is equal to negative 2. And then dividing by 7 on both sides, we have x is equal to negative 2 over 7. For the other equation, we can add 7 to both sides. So we have 3x is equal to 7. And then dividing by 3 on both sides, we have x is equal to 7 over 3. So These are our two solutions. So now we have to know how to factor for the remainder of these problems. So to recap, anytime you have an equation, I guess it'll be best if I just write out this one. So for 17, we have v squared plus 2v minus 35 is equal to 0. So anytime we're trying to factor a quadratic like this, the goal here is to find two numbers that multiply to negative 35 and add up to negative 2. So through a little bit of trial and error, you can figure out that those two numbers are positive 7 and negative 5, because we have negative 5 times positive 7. That's equal to negative 35. And then if we have negative 5 plus 7, this is equal to positive 2. So we know that these are our two numbers. And so that means that we can break this up, and we can factor it as v minus 5 times v plus 7, which is equal to 0. And I'll explain in a moment why that works, but we have this broken up now as v minus 5 times v plus 7, and now this is like the previous problems that we just did. We have v minus 5 is equal to 0, or v plus 7 is equal to 0 by our zero product property. So v is equal to 5, or v is equal to negative 7. So I know I've gone over this in class before. However, I just want to recap why that works real quick. Basically, if we multiply some two binomials like this, if we have x plus a times x plus b, and if we multiply these together, we'll go over multiplying polynomials later in this series, but I'm sure all of you have by now seen me use this box method at least 1,000 times. But we have x plus a times x plus b. We have an x squared from our x times x. A times x is ax. X times b is bx. And a times b is ab. And so when we add all of this up together, we get x squared plus ax plus bx plus ab. And if we combine like terms, we get x squared plus a plus b times x plus ab. And so, sorry, my dog is drinking water right now. But notice that now we have those two numbers, a and b. They multiply together for this last number here, and they add together for this number in the middle. So that's why finding those two numbers to factor like this works. So for number 18, we have m squared minus 10m plus 16 is equal to 0. We want to find two numbers that multiply to 16 and add up to negative 10. By the way, when trying to find the two numbers that do that for us, I always try to start with the numbers that multiply. There's basically a ton of different numbers that you can think of that add up to negative 10, but there's considerably few that are going to be integers that multiply to something like 16. So just a word of advice when tackling problems like this. But if we think hard enough, we'll find that we have negative 8 and negative 2. So we have m minus 8 times m minus 2 is equal to 0. And as you've probably noticed with a lot of these, where we have no coefficient in front of our variable, so we have implicitly a 1m here and a 1m here, we can just flip the signs on this, like this -8 and this -2. And so we can always use our zero product property, and we should when we have a coefficient other than 1 here, like this 7x. But if these coefficients are just 1, we can just flip these numbers. We have m is equal to 8 or m is equal to 2. For number 19, we have v squared minus 14v plus 49 is equal to 0. We find two numbers that multiply to 49 and add up to negative 14. And we have v minus 7 times v minus 7 is equal to 0. Flipping these signs, we just have v is equal to 7 or v is equal to 7, which really just means we have v is equal to 7. If you remember from our discussion on the fundamental theorem of algebra, we could say that this solution, v equals 7, has a multiplicity of 2. So just reference back to that assignment. Let's look at number 20. For number 20, we have n squared minus n minus 6 is equal to 0. Finding two numbers that multiply to negative 6 and add up to an implicit negative 1 here. We have, let's see, we have negative 3 and positive 2. So n minus 3 times n plus 2 is equal to 0. So our solutions are n is equal to 3 or n is equal to negative 2. All right, so that's all the room we have on that page. Let's go over to the next one. We have number 21. Number 21, now for these last four, they're not in standard form, so we want to rearrange this a little bit. For number 21, we have n squared plus 21 is equal to 10n. So moving 10n over to the other side, we have n squared minus 10n plus 21 is equal to 0. And now this is in a form that we can factor, a familiar form. We try to find two numbers that multiply to 21, but add up to negative 10. Chai, come on, man. Thanks. All right, sorry about that. So we have two numbers that multiply to 21 and add up to negative 10. It's going to be negative 3 and negative 7. So n minus 3 times n minus 7 is equal to 0. And we can just flip the signs on these two numbers. And we get n is equal to 3 or n is equal to 7. For number 22, again, we're not in standard form, so we have r squared plus 7 is equal to negative 8r. For this one, we, let's see. Yeah, we want to add 8r to both sides. So we have r squared plus 8r plus 7 is equal to 0. And we want to find two numbers that multiply to 7 and add up to 8. We have the numbers 1 and 7, so r plus 1 times r plus 7 is equal to 0. Flip the signs on those two. Then we have r is equal to negative 1 or r is equal to negative 7. For number 23, we have x squared is equal to negative 7x plus 8. Not in standard form, so we want to get everything to the left. We can add 7x and subtract 8. X squared plus 7x minus 8 is equal to 0. And now we need to find two numbers that multiply to negative 8 and add up to 7. These two numbers are going to be positive 8 and negative 1. So we have x is equal to negative 8 or x is equal to 1. For the last one, for number 24, we have v squared is equal to negative 3v. So there's two different ways that we can look at this. First, let's get everything over to the left. We have v squared, plus 3v is equal to 0. So first, just from our, as we've seen in this class, there's we've gone over different factoring techniques. What we should be able to observe by now is that because we have a common factor of v here, we can do this, we can factor out that v. We have v times v plus 3 is equal to 0. Our zero product property tells us that this is going to be v is equal to 0 or v plus 3 is equal to 0, which means that v is equal to negative 3. And so that's one way that we can go about this. The other way that we can think of this is observing that we have v squared plus 3v, and implicitly we have a plus 0 here. So if we want to continue factoring like we have in the previous problems, what we can do is find two numbers that that multiply to 0 and add up to 3. Well, if they multiply to 0, from our zero product property, we have that one of those has to be 0. So 0 plus what number gives us 3? Well, that has to be positive 3. So we can think of this as our two numbers being 0 and 3, which, flipping the signs on those again, negative 0 is just 0 still, so v is equal to 0, or v is equal to negative 3. So either way, we get v is equal to 0 or v is equal to negative 3. Either way you choose to look at that is perfectly fine. But that concludes section 2 for our final exam review. So I will see you on the next one.